There we go. All right, so we are going to watch a little video that's going to introduce an activity today that we're going to start our next chapter with. So, boop. Full screen. All right. Yes, it's about chocolate milk. I do not have chocolate milk for you to drink. Sorry. My Nana likes her chocolate milk made with just the right amount of chocolatiness. So I should have added 1 cup of milk, 1, 2 scoops, 3 scoops, 4 scoops. Dodging. Uh-oh.
No, boy.
Oh, no.
Too much chocolate. What's the chocolate?
Nana's picky. So it should have been 1 cup of milk and 4 scoops or spoons of mix. Oh, goodness, that is starting the worst activity. We're not doing that one. And what we accidentally did was 1 cup of milk and 5 scoops. But I can't pull the powder back out because it already got wet. I can't unmix it. So I want you to figure out how to fix it. Ooh, I like that one too. Talk to each other. Find more of the solutions. Don't just rely on Noah. Because there's a lot of different options here. I'm just closing this because that is. There we go. Thus the intent. Same ratio, bigger. Yeah. Well, maybe that's our last cup of milk.
Oh, that's
Or puts us really close to our last cup of milk, our last full cup of milk. Or Nana's not only picky about her chocolateness, but really picky about food waste.
We could add more milk to the glass.
We could add more milk to the glass. Okay, which is what I heard Noah say first, was if I make this 1 1/4 cups of milk, I don't even have to add any powder. It's still good with 5 scoops. Anyone else do it a different way? Yeah, Celeste, what did you do?
If like you add more cups of milk
Mm-hmm.
and more scoops of the powder, it's the same ratio, just like
Yeah. So if we add like 1 more cup of milk and we add 3 scoops, that would put us at the same ratio. We're going to be doing a lot of things with ratios here. No, you accidentally lead yourself into the action for my next one. Because usually it's that we just add another cup of milk, we add 3 scoops. If my cup doesn't fit 2, we then have to scale it down. Because all this chapter is going to be about unit conversions and scale and playing with ratios and all that kind of stuff. So we are going to be fractioned up in this chapter. So don't be afraid of fractions. Okay? So that was just kind of like a silly, fun way to kind of get us into this unit conversion thing. No, I don't have chocolate milk for you. Sorry. I bring relative treats for a lot of things, but not that one. It's 7th period. You don't want counter temperature milk from 7th. It would be warm.
You should get a mini fridge.
I don't got mini fridge money. Okay. So what we're going to do, our for realsies starting activity is going to be on page 118 in your book. So get your books out. And we are shockingly close to the end of this little workbook. Like,
Why is the units out of order?
because Unit 8 can fit really anywhere, but Unit 8 is long, and also Unit 7 is long. So we really did not want to end with two really long, really mathy concepts when we're seniors headed into our final semester, and telling you what, come May, I'm not going to be able to get you to do two big projects like that. So it's a way to kind of fight that. So yeah, we did 1, 2, 8, and then 3. Because that put 8 in here, so our two biggest chapters, we had one big chapter in first semester, one big chapter in second semester. It gives us a lot more space schedule-wise. And then we're also not ending a semester with that project and with all of that data memorization stuff. Okay. So what you're going to do is you are going to find your pulse. And for most of us, somewhere under here is going to be where you can find it. You might be able to find it in your wrist. I have never in my entire life been able to find my pulse in my wrist. In my entire life. I have to like way in here to find it. But I want you to find the pulse in your wrist. I'm going to time it for 15 seconds, and you are going to count how many bumps you feel. Okay? So once I tell you to, start counting. Has everybody found their pulse in their neck or wrist or wherever? Because we're going to be using this number a couple of times. All right, ready? Go. Stop. Write that number in this box. However many bumps you felt, write it here. And it's going to be an estimate. So everyone's going to have a different number. And I'm going to pretend mine was 20 because I was watching the timer, so I didn't actually measure because I did that and then I couldn't count and watch a number at the same time. So if I had 20 beats in 15 seconds, how could I find out how many beats in 1 minute? So yeah, it's gonna be it's gonna be kind of like that, but the way we do it is with a unit conversion. Cause I know something about seconds and minutes, right? There are 60 seconds in 1 minute, right? So I can cancel out the word seconds and the word seconds because it's the same word. I just spelled one out and abbreviated one. So it's going to leave me with the words beats per minute. So we're going to take our 20 times our 60 divided by 15, which is going to wind up being times 4 because the 15 cancels out. So for mine, I'm going to wind up with 80 beats per minute. I want you to find your beats per minute. So next to the box. So there's this random amount of white space next to this box. Find your beats per minute, because what you have is beats per 15 seconds. So find your beats per minute.
Where should we get 80 from?
I multiply 20 times 60 divided by 15.
Oh.
So you're going to take your number times 60 and also divide it by 15. So that's what we're calling your resting heart rate. We've done a resting heart rate. I think we should probably do an active heart rate.
Yes.
I can't run that.
You're right, you can't. So, alternatives. Some of you are going to respectfully, notice that, respectfully run down to F hallway and back.
What?
Or just sit here and go, because that actually makes your heart rate go up really fast. If you sit here and like hyperventilate, you can absolutely go run down the hallway to F and back. Anybody want to run?
I'll do it.
Just see if you get an active heart rate, or you can like stay here and like do this, or just like, because that'll put, or like hold your breath, because that will also put your heart rate up. If you hold your breath as long as you can, like until you're about to pass out. F hall, that way. To the wall and back. You're not
I've been
ready
in
to
this school
school.
for 4 years.
They go race. Okay, so get your heart rate up because we're going for an active heart rate. You can also like, oh, you leave happy, whatever. But we want an active heart rate. They want you to run. I'm being nice. I'm giving you alternative choices. But get your heart rate up. It's good for your heart health too. Yeah, absolutely, absolutely.
Oh,
All right.
there were the teachers like, are you guys okay?
Yeah, I usually warn the people down the hallway about it, but I forgot to today. So.
There's no way that's an actual experience. There's no way that's an actual experience.
Oh.
I forgot that they do dismissal right at this time. All right, so you're gonna take your heart rate again. Just take your heart rate again while your heart beats up and high. Okay, so I'll put it up here this time. All right. Let's go with timer. Okay, go. Stop. You're going to do the same thing. I'll leave it running for those of you that needed to be seated to get your heart rate active. Okay, so you're going to do the same thing. You're going to find your beats per minute of an active heart rate. Close that because it's just going to distract me the heck of the way.
Would it be the same equation?
It's going to be the same equation. Yeah, we're still gonna. We still did 15 seconds. If you count like a different unit of time, it'll wind up different. But since we still did 15 seconds, it'll be the same calculation. And that's what's going in box 2, this second one down here. So this is your active heart rate, or your breath holding heart rate, or your running down the hallway heart rate. So find your beats per minute for there again, because we're going to do some calculations in there. We're going to use your data about your heart. What's up? Yes, dear. Uh-huh. Stylus just died. Boo. Very good. Okay, did you find your beats per minute?
Yes.
Awesome. Because what we're going to do next is we're going to look at exactly the next question on that page. I want you to find out how long it will take for your heart to beat 700,000 times. How many minutes, you found beats per minute, to get 700,000 beats?
For your resting or your.
We're going to do it once for each. Wahahaha. Okay, so see if you can figure it out. Try it by yourself first. You guys have done conversions like this before in your lives. See if you can figure out how many minutes and everybody's going to wind up with different answers because we have different resting heart rates and different elevated heart rates. Trying to fix my stylus. What's your thought on how to do this? How could we figure this out? We can use my regular resting as 80. So if my heart rate is 80 beats per minute, for 1 minute. And I want to know how long it takes it to beat 700,000 times. How can I figure that out? What's your instinct? If I know it's 700,000 beats, and I'd like to know what unit of time it is, we're going to multiply by something that'll make my beats cancel out. So I'm going to take my heart rate, and I'm going to flip it. It's still the same relationship. I still have 1 minute per 80 beats. But do we see why that might be helpful? Because then I can take the word beats and cancel it out. So whatever our unit is that we would like to cancel out, we want that to be on top and on bottom. Because then we're going to multiply across. This is an over 1. And we're going to wind up with 700,000 divided by 80. And the only unit we have left is minutes, right? Hopefully vaguely familiar. So for me, if I take my 700,000, oh, that one's dead. 700,000, and I divide it by my heart rate, dividing by my 80, I get 8,750 minutes. Super awesome. We love that, right? How the heck long is that? That's all well and good, but realistically, I don't know how much that is. So how could we switch this to be hours? What can I do to switch this to be hours?
60 minutes.
Yeah, 60 minutes in an hour. So 1 hour is 60 minutes. And we can cancel out the word minutes to get 8750 for me, divided by 60, and I get 145.83 hours. Again, great. How long is that? Can we?
Divided by 24.
Yeah. So if we divide by 24, that'll get us into 1 day is 24 hours. So if we divide that by 24, I get 6.076 days. But I want to be as specific as we can. So I know it's going to be 6 days. How can I figure out how many hours not inside the 6 days it would be? I want to be like 6 days, 2 hours, 27 minutes, whatever it's going to be. How could I figure out how many hours in that remainder?
2 down 6. So that's 0.8.
We can do that. Still not going to change our situation here. How many hours is 0.8 or 0.08 of a day? 8%. How can I find 8%?
Divided by 24.
Close.
60.
Not dividing by 24.
Multiply
I need to multiply. Now I'm working back the other way. So our 0.08 times 24, I get 1.92. 1.92 hours. So then I want to find out the number of minutes. So we're going to look at our decimal here to get specific. 0.92 of an hour is going to be about 55 minutes. We're not going to go into seconds because we rounded a couple of times. But so for my heart to beat 700,000 times would be 6 days, 1 hour, and 55 minutes. So we're going to do a lot of times where we have conversions like that and we look at units of time and we make them be like realistic statements. Like no one says, I have to go back to work in 145 hours. But when we go on fall break, you can bet we'll know that we come back in 7 days and 12 hours. Like, that's math we know how to do. That's math we use. Okay? So it's all about putting things into context for real life. 700,000 beats is all well and good, but 6 days, an hour and 55 minutes, that's something we can visualize. We know how long that is. We have one more question on this page that looks at things in a slightly different way, but it's using the same thing. You are training for a 5K race, and this morning You ran 8 miles in 1 hour. How long will it take you to run a 5K race? So these are in different units. You either need to know how many kilometers in a mile, or you need to know that a 5K is 3.1 miles. So I want you to see if you can figure out how long it would take you to run. This is a calculation that runners will do. My husband does marathons now for some reason. He's made a choice. Whatever. Well, let's go. So he actually has had me, because he doesn't like math, has had me do this math for him. Okay, but this is printed in the book. If you ran 8 miles in 1 hour, and you use the same pace to do a 5K, how long would it take you, as specifically as you can? This is one of those that feels super simple, but it winds up being a little more complicated than one thinks it might be. Okay, I'm going to put up mine, the way that I did it. I took my rate, my speed that I ran 8 miles in 1 hour, and since I know I'm looking for time, I put the hours on top. So I did 1 hour in 8 miles. Since I want to know how long, how many minutes, I want to know time. Time goes on top. Okay, so thinking about what we're looking for, that should always be in our numerator. I want to know time, so I take my speed and flip it on its head. 1 hour per 8 miles, which means I want my miles to cancel out. So I put 3.1 miles on the top so that I can cancel out the word miles per 5K. Now I could multiply the 8 and the 5, which is going to be something a lot of us are really tempted to do. But I don't want to know how many hours per kilometer. I want to know how many hours per 5K. So I'm going to leave the 5 in there. I don't need it to be gone away. have that upside down. So I'm going to really just take my 3.1 and divide it by 8 to figure out it's 0.3875 hours per 5K. Everyone see how that came to be? Because it's weird. But once we get through it, it's okay. Because then our last bit is to put this into terms of minutes. How would I get this to be minutes? Multiply by 60, because we have hours currently. And so if we multiply it by 60, we get 23.25 minutes. Or 23 minutes. And how many seconds are in a quarter of a minute? 15 seconds. So we're going to be working a lot with unit conversion along with scaling and things like that. So it starts out very, very, very fractiony and will continue to be very, very fractiony. But this is the last chapter in the book. So you can kind of peek and see this is all we got left. Like, this is it. Okay? So honestly, we really have a week before Thanksgiving, so this week, a week after Thanksgiving, a project, and then reviewing for finals. Okay? Okay. Not too bad. Not too bad. That means since this is the last chapter, we do have some new homeworks pulled up onto the Canvas page, and there are 3 homeworks in this chapter. However, all 3 of them are this week. So usually it averages to 1 to 2 homeworks a week. Well, this is outside the week, outside the average. We are an outlier this week. But it's the last 3 homeworks of the semester. We tolerated, okay? So 3.1 is, it's called heart rate. It's practicing taking the heart rates, putting them either into beats per minute or things like that, doing unit conversion on time like we did. So it's very, very much based on what we did today. Again, we're going to have a project for this one. It's going to be due December 8th, and after that, it's going to be reviewing for finals. Alrighty? Huzzah. I promise I will get to projects this week.